All right, we're going to do 7-4. The warm-up you can go ahead and do, that's by substitution. And then we are going to use a new method today. So remember that to solve systems of equations, we are looking for the point where two lines intersect. So we need an x and a y. We have done it with graphing. So we've graphed them and then physically found where they intersected. We did it with substitution, where we knew one of them and plugged it in. And now we are going to use a new method today called elimination. Elimination is exactly what it sounds like. You are eliminating a variable. Specific things have to happen in order for elimination to work, but if it's already set up and ready to go, it's pretty simple and easier than substitution in a lot of cases. In order to use elimination, you have to have matching numbers with the same variable. So you have to have like a 2x and a 2x, or a 7y and a 7y. They have to match. The opposite signs is something that we would like to have. You'd like to have opposite signs, but it doesn't necessarily always have to happen. If we have control, we're going to make them have opposite signs. But if we don't have control, we can deal with it if they don't have opposite signs. But the matching numbers is a must. You have to have matching numbers. So first thing, make sure you got matching numbers, preferably with opposite signs. You are going to, once you have that, add straight down, like old school addition, to, in the process, eliminate a variable. So you used to have both x's and y's, and then once one of them's eliminated, you'll only have x or only have y. So then you're going to solve for whichever one's left, and then plug it back in, because of course we still need a point, so we need an x and a y when it's all said and done. So if we look here, if we wanted to use substitution, which we were just doing, we would have to isolate one of these variables first. And if you remember, they're easiest to isolate if they do not have a coefficient. All of those variables have numbers in front of them, which is going to make substitution way more complicated. Okay? However, we have a new method that will work here, because in order to use elimination, you have to have matching numbers. So right here we see 5y and 5y, so that way we can know we can eliminate because those y's match. In addition to that, they have opposite signs. Okay, this is a -5 and this one is a +5, which makes our lives easier, and we'll explain that a little bit more later. But the fact that we have matching numbers with opposite signs means that we can eliminate, so we can add these two equations together. 3x plus 2x is 5x. -5y plus 5y is 0. They're eliminated, which is the goal. Equals -16 plus 31 is just 15. So all we did was add straight down, and in the process my y's got eliminated, and now I have something super easy to solve. So 5x equals 15, divide both sides by 5, and we get that x is 3. We cannot be done because that's only half of a point, and we need to know y as well. Now, it's not going to be as easy to plug them in as it was with substitution, so this part's a little bit harder. But you pick whichever equation you want. And I'm going to pick the second one here because it doesn't have any negatives and it just looks a little bit simpler. So, but it doesn't matter, you should get the same thing either way. 2, we now know that x is 3 plus 5y equals 31. 2 times 3 is 6 plus 5y equals 31. Subtract the 6, so 5y equals 25. Divide by 5, so y is 5. Now, we now know x and we know y, so we know our point is 3, 5, and that is where the two lines intersect, and you can always check it in Desmos. All right, let's try another one. We see right off the bat that we have these y's that match. They're both 1y. They also have opposite signs, so since the y's match, we can just add these straight down. 2x plus 4x is 6x. 1y plus -1y is no more y's. All gone, they eliminated. Equals 18 plus 12 gives us 30. And now it's super simple. Just divide by 6. 30 divided by 6 is 5. So x is 5. We do have to plug it back in. Whichever one looks easiest to us. I think I'm going to go with the first one because there's no negatives. 2. We now know x is 5 plus y equals 18. And then we're solving. 2 times 5 is 10. Plus y is 18. To get the y by itself, we have to subtract the 10. 18 minus 10 is 8. So y is 8. Final answer, 5, 8. And that's the point where the two lines intersect. You can go ahead and do this one on your own, just like it says, on your own. Now, if we have matching numbers and matching signs, then we can still eliminate. So if we're given matching numbers, we can make an elimination no matter what. But you have to subtract the two to make sure they're eliminated, which gets a little tricky because you have to subtract everything, and sometimes it's hard to keep track of your signs. So you just have to be careful if you need to subtract. So if we're looking at this, these two t's match, but they are both positive. Okay, so if we added them, okay, they would give us 4t. That's not the goal. The goal is to eliminate the ones that match. We need to get rid of the ones that match. So in order to do that, I'm going to have to subtract. Okay, so I'm going to subtract everything. 5s minus 9s is a negative 4s. 2t minus 2t cancels. That's the goal. Equals 6 minus 22 is a negative 16. Then we just divide by negative 4. Negative 16 divided by negative 4 is positive 4. And then you just have to plug it back in. So once you get the subtraction done, it's normal. I'll pick the top one because it looks like the numbers are smaller. 5, we now know that s is 4 plus 2t equals 6. 5 times 4 is 20 plus 2t equals 6. Subtract the 20 over, get negative 14. Divide by 2, and you get negative 7. Alphabetical order, s comes before t, so in your ordered pair it goes 4 and then negative 7. And that's it. We'll do one more subtraction. Just watch your signs. So the x's match. Now be careful because you see, oh, here's one positive and one negative. But those go with the y's, and we need to eliminate the x's. The x's themselves are both positive, so we're going to subtract to get rid of them. X minus x cancels. Watch your signs. This is a negative 3 minus 2. Okay? Negative 3 minus 2 is negative 5y equals 7 minus 2, which is 5. Then you divide. 5 divided by negative 5 is negative 1. And then you just pick whichever one you want to plug it back into. I'm going to do the second one. It doesn't matter. X plus 2. We now know y is negative 1 equals 2. So 2 times negative 1 is negative 2. To move it over, we're going to add it. 2 plus 2 is 4, so the x is 4. There we have both the x and the y. So our final answer is 4, negative 1. And that gives us the point where the lines intersect, and you can check it in Desmos. You can go ahead and do this one on your own, and then your 7-4 worksheet.